continuing with part 2 of our study guide. We're going to pick up on 15. I did go through on your test before I turned it in to be sure that each of the arrows were there. In this question, they're still asking us for the domain and the range. And while this domain might look like there's nothing in this area over here, the arrow there indicates that this domain will go on forever, and this arrow indicates that this domain will also go on forever. So the domain for this is negative infinity to infinity, and those are always rounded. Another choice would be all real numbers, and I tell you both of those because some of these are multiple choice questions, so you might want to make a note of that. Now the range is a different story with this problem. This is the smallest value, or the minimum, that you will ever see on this parabola. We know a lot about this from our studies. We know that this is an even function because it starts up and ends up. We know that it's a positive leading coefficient because it starts up. If it was a negative leading coefficient, it would start down. Okay, and we'll talk more about that in just a moment. But all this question asked you was for the range. So the range, the smallest value that this ever gets is -3. And this does include -3, so it will be a squared off one. So it goes from -3 to infinity for this range. Okay, for question number 16, again, I'm going to be very clear that this is going to go on here so that you can see that it goes on and there. Those arrows will be there on your test. So this is kind of an unusual function in that it has some pieces that are increasing, decreasing, and constant. But this particular one just asks us for the domain. So the domain in this problem is, again, all real numbers because you see that it starts in negative infinity and goes to positive infinity. So the domain is all real numbers, or negative infinity to infinity, and those are rounded. Now, the range is a little different. The smallest that this will ever be is 0. And the largest that this will ever be is 7. Because we have to assume that this stays constant forever because we have no other indication. And this stays constant forever. So the range for this problem is going to be a squared off one because, now I want to make sure you realize this is rounded. This one is squared off because it includes the 0. And it also includes the 7. So those are both squared off. So the range goes from 0 to 7, and that's it. Yes. Continuing with number 17, this is a line. And a line is kind of unique in that it always has a domain with 2 exceptions, and I do want to talk about the 2 exceptions here today. But before we do that, let's say that the domain is this, negative infinity to infinity. The domain for a line is all real numbers, unless we have these 2 special cases that I'm getting ready to remind you of. And the range is also negative infinity to infinity. So a line is pretty special because the range and the domain go forever in both directions, unless it is a 0 slope. So here's an example of one that is a 0 slope. This line that says x equals 3. So in this particular line, the domain still is all real numbers. But the range on this one is only 3. You see why this line is different? So the other exception is this one. It is when we have an undefined slope. So here is this, and it will be x equals -4. So in that case, we have the domain that is not all real numbers, but is only -4, right? That's it. And the range is all real numbers. So there are two kind of exceptions there, two lines having infinite domains and ranges. Okay, question number 18. Again, I'd like to see the arrows on this. I think I carefully marked them on the test. But in this instance, our domain is all real numbers, -infinity to infinity. And our range is -infinity to 1. Now, in another class, some people were saying, isn't it 1 to -infinity? And the answer to that is no. The smaller number comes first. So it's -infinity to 1. The infinity is rounded, and the 1 is included. So there is the domain and the range for those. Okay, in question 19, we have identifying the intervals where the function is changing, increasing, decreasing, and constant. So I wanted all three of them on here. And I do want to point out that there should be 3 answers here. So increasing, and remember that these intervals are always rounded because you can't be increasing or decreasing at a point. So let's go ahead and use our interval notation. This function is decreasing here until we get to 3. So it is decreasing from -infinity to 3. And then it turns and begins to increase. Remember, when you tell if a function is increasing or decreasing, you're looking at the point before it and the point after it. So for example, if we were taking this point, isn't the point just to the right of that bigger? And the point just to the left of that smaller? So if that's true, then this is an increasing function. So this function increases on this section beginning at 3. So this function increases from 3 to infinity because it's halfway between 2 and 4. You use the x values to note the interval. So that's a good thing to recall. These are the x values, not the y values. Okay? You thought it was 2 because you were looking at the y value. To do the intervals, you use the x values. This particular function is not constant on any interval. Okay, page 7. Again, we're looking to see if this is increasing, decreasing, or constant. So let's make a note that these go like this. So in this function, it would be constant first. And it would be constant from -infinity to -3. And it would also be constant over here from 2 to infinity. So we would put those two sets together, and that is the intervals on which it is constant. This is decreasing from -3 to -2. So this is decreasing from -3 to -2. And this would be increasing from -2 right here all the way to 2. So -2 to 2 using interval notation. So in that graph we had all 3, increasing, decreasing, and constant. Sure. Okay, 21. Increasing, decreasing, or constant. This one does stop. So maybe that was the confusion. This one has a definite endpoint.
Yeah.
I made those really clear on the test, but this one goes on forever. So we have an increasing section first. And some of you I know are going to be tempted to square this off, but remember The intervals are always rounded when you're telling about increasing the slope, increasing, decreasing, or constant. So this is going to start at -2 and go to -1, and it's rounded. And it's also going to increase from 3 to 5. So 3 to 5. And those are both rounded. These intervals are always rounded. Oh, you're right. You're exactly right. This should go to infinity.
Oh my God.
I got distracted. I won't name names, but somebody distracted me. Who did that? 3 to infinity. Thank you very much. You want credit? I'll give you credit. Michaela. Now what about decreasing? What sections is decreasing? Just the section from here to here. So again, we use the x value, 1 to 3, to name that, and then does stop. And then we have this constant piece that's right here. This is the constant piece. And it is -1 to 1.